Hello and welcome to my channel again. Today we have Volvo XC60 with 2.4 D engine. The vehicle has symptom that the engine has no power when it reaches its operating temperature, and the engine reduces its power, and also the gear is not shifting upward. So we are going to investigate this today together. So the other thing is that the engine management light is not showing to that. Let me start the engine. As you can see, the engine management light is not showing up on the dashboard, and the vehicle is okay for as far as it's cold. When the engine reaches its operating temperature and the engine goes to a limp mode home. So I have already taken the scan data recorded or report, and now I'm going to show you that video as well, because yesterday I played with the engine and with the with some sensor connector, so I'm not sure whether the fault code will still be in the engine, the ECU memory stored, or it would not, because since yesterday after that we have cleared or deleted the fault code, we have not driven the vehicle, so probably the fault code will not be stored in the memory yet. So let me show you the yesterday scanning report. So I'm going to show you the fault code report. Okay, this is the vehicle detail, and these are the fault codes. One P0029900. It says turbocharger A, under boost condition, general fault information, no subtype information. This is one, and the second one is P004C00, turbo charger boost control, B circuit low, general fault information, no subtype information. So this is the scan report which I retrieved yesterday from the vehicle. So now I'm going to go back to the home page, and I'm going to scan the vehicle again. So I'm not going to scan all electronic units, so I'm going to select the one which we need. So it's going to be the ECM, so treble codes. So it says no treble codes because as I have previously mentioned, that we deleted yesterday. So since yesterday we have not driven the vehicle, so the vehicle was stationary. We have just started this morning the vehicle. So that was the fault code that I have shown. Right. Now we got both fault codes retrieved from the engine control unit. So one is the P004C turbocharger or supercharger boost pressure circuit turbocharger supercharger boost pressure control B circuit low, and the other one is P0299 turbocharger or supercharger low boost. So to investigate these two fault codes, so first we are going to check the boost pressure sensor. So to check the boost pressure sensor, so we are going to go to the component location. So we will go here, and we are going to select electrical component location here. So we are going to scroll down that, so we are going to enlarge this. So here I'm going to show you that turbocharger boost pressure sensor and intercooler, which is wrong. I'm going to select that. This is number 23. if I go here, it's marked here that is located in the intercooler. As you can see, turbocharger boost pressure sensor is located in intercooler. So it says in the O2 data here, but it's completely wrong. It's actually located here on the inlet manifold here. So for this particular vehicle, which is this one, so with the engine code B004C00, so the boost pressure sensor is located on the inlet manifold. So I'm going to go back and I'm going to select engine management. So I'm going to select wiring diagram. So then I'm going to select the turbo boost pressure sensor here. Yeah, this is turbocharger boost pressure sensor. I'm going to select this one, and as you can see, it's on the wiring diagram here. So the sensor itself is called B105. It actually got 3 wires. So the first wire, the green and the brown wire, which is connected to pin 1 at the sensor, this is the signal wire. And pin number 2 wire, blue color wire, which is connected to pin number 2 at the sensor, this is the 5-volt reference wire. And white and brown wire, which is connected to pin number 4 at the sensor, this is the ground wire. So the green and brown is the signal wire, and the blue is the 5-volt reference wire supplied by the ECU to the sensor, and the white and brown wire is the ground wire for the sensor connected to the ECU. So if I go to here, so more information, so component check. So actually it says 2 and R, ignition is on, it's 5 volts. So it means that the 2, which is blue wire, it's the reference voltage or 5 volt reference wire. So now I'm going to go to the because I have to go to the control module pin data, otherwise I cannot check the 2 wires. So the wire which is connected to pin 1 at the sensor and wire which is connected to pin 4 at the sensor. If I select this one with the signal control module pin data with the signal turbocharger control with the twin, this is going to be our turbo because our is single turbo. So if I go there, so as you can see, so this wire which is connected at the sensor at pin 2, and here it's connected to the ECM at pin 18 and connector A. This is going to be the 5-volt reference wire, and this is which is the input signal to the ECU. This is going to be connected at pin 1 at the sensor, and here at pin 78 connector A at the ECU, and this one is going to be the ground wire for the sensor, and this is this wire is connected at pin 4 at the sensor and pin 82 connector A at the ECU. So we should have this data. So if we turn the ignition on, we should have value of 5 volt from the pin number 2 or blue wire. And also when the engine is idling, we should have 1.3 volt input signal to the ECU from pin number 1 at the sensor or green wire at the sensor. And also we should have a solid ground when the ignition is on from the pin number 4 at the sensor or white and brown wire. So now we are going to put this theory in practice. So once again, I'm going to go back to the wiring diagram and show you here. So okay, as you might be able to see here a little bit better if I zoom that out. So okay, pin number 1, this one here, green and brown is going to be the signal wire to the ECU, and this is connected to pin 78 at connector A, and this blue wire is going to be the supply voltage to the sensor from the ECU, and here it's connected to pin 2 at the sensor and pin 18 at the ECU connector A. So this white and brown wire is going to be the sensor ground, and it's connected to the sensor at pin number 4, and pin 82 connector A to the ECU. So when the ignition is on, we should have 5 volt voltage reference here. So when the engine is idling, we should have I think it was 1.3 something. Just let me check. I'm going to check it again. So okay, signal wire, it was 1.3, so that's right. So I'm going to go back to the wiring diagram. Okay, so when the engine is idling, we should have 1.3 volt at the signal wire, and we should have 0 volt here when the ignition is on at pin number 4 at the sensor. So let's go and put this in practice. Okay, this is the boost pressure sensor located here, and instead it's mentioned in the auto data on the boost charger intercooler, which is not located here. Instead it's connected here, and this is the wiring diagram. As you can see, this is going to be pin number 1, and this is going to be pin number 2. So the blue wire is going to be the reference wire, 5 volt reference wire, and this one is going to be the green and brown trace on it. It's going to be the signal wire, and as you can see, the engine is idling. We should have 1.3 volt, and this pin number 4 is going to be the sensor ground, and pin number 5 is pin number 3 is empty, as you can see. So I'm going to connect the black lead of the scope meter to the ground wire to pin number 4 here. And now I'm going to connect the positive lead of the oscilloscope to pin number 1, which is the signal wire. And now we have 1.22 signal. So now I'm going to remove the boost pressure sensor and apply some pressure to the pressure sensor and see if the voltage is changing here. Okay, now I'm going to remove the sensor. Okay, I have removed the sensor. As you can see, this is very, very dirty. So I'm going to first clean this. So I'm going to sensor as well, as you can see, and this hole was completely blocked. Too much carbon was built, and now I have thoroughly cleaned that. So now I'm going to clean the sensor too. So I'm going to clean that one too. Okay, as you can see, I have thoroughly cleaned the sensor. As you can see, now I'm going to connect the sensor. I have connected the sensor back, and this is the hand-operated vacuum pump. I'm going to connect the vacuum pump to the sensor here. Okay. So I have turned the ignition on, and as you can see, we have 1.16 voltage with only ignition on. Now I'm going to apply some pressure to the sensor. With the ignition on, no pressure applied to the sensor. As you can see, it's 0, and we have 1.19. Okay, as the pressure goes up, the voltage on the scanner screen goes up to, as you can see, 1 bar pressure is applied, and we have the voltage on the oscilloscope 2.21, because the pressure is decreasing. So now I'm going to increase the pressure again. It's exactly, so it means that the boost pressure sensor is responding according to the pressure. As you can see, it's exactly 1 bar and the voltage is 2.51. So if I decrease the pressure, and the voltage is also decreasing, so it means that this one is responding to the pressure as well. So now, because I have thoroughly cleaned the sensor and the sensor port 2, now I'm going to put that back on, and we are going to start the engine, because previously we had 1.2 volt of the signal wire. So now I'm going to start the engine again and see if the voltage is increased to 1.3 while the engine is idling. Okay, now I'm going to start the engine, and you watch here. Okay, as you can see, it did not make any change cleaning the sensor. We still have 1.2 volts. And also we are going to check the charge air pipes or system for any leakage. Engine ka raise barka. Raise barka. Back. Let me bring that out. So as you can see, the turbo wind actuator is not moving at all when you're revving the engine. So it's not moving when the engine temperature reaches above 105 degrees of Fahrenheit. Rev the engine! Rev! As you can see, the wind actuator bar is frozen. It's not moving at all. So next step, you are going to replace the turbo unit, because as soon as the engine temperature reaches above 105 degrees of Fahrenheit, so the carbon does not allow the wind to move by the wind actuator bar. Dame now record. Okay, with the ignition. Okay, turn the ignition off. As you can see, the bar is not moving at all. It's stuck. Wait. Start the engine. Bar is not moving at all. Okay, as you can see, there. Ignition off. Okay, with the ignition off, the bar is not moving at all. It's frozen. Wait. Ignition on, only ignition on. On. The ignition is on. Okay, with the ignition on, the bar is not moving at all. Start the engine. It's not moving at all. It's frozen in one position. So on. Start the engine. On. Ignition on. The start engine. Off. The bar is not moving, even though I have cleared the fault code in case that with the fault code the engine is in limp mode, but when I clear the fault code out, the bar is still in freeze position. So it means that the turbo unit has to be replaced. I have just cleared fault code. Now I'm going to check if the fault code, any fault code, return back. So now check fault code. This fault code has returned back. P004C turbocharger. The turbo unit is faulty, mechanically faulty. The turbo unit is mechanically faulty. Okay, now I'm going to turn the ignition on. Okay, I have turned the ignition on, and now the ignition is on, and now I'm going to start the engine. Okay, as you can see, as soon as the engine has started, this bar has moved downward. So when the ignition was on, the bar was lined up with the mod. Now the engine is running, the engine is idling, and the bar has moved downward. So as soon as the engine temperature reaches to 70 degrees of Celsius, this bar remains stuck at the mark, at the blue mark, so it's not moving at all. So for this reason the fault code is good. As you can see, the bar is located down. Okay, now the bar is down and the engine is running. So now I'm going to turn the engine off. So now the engine is off, and you watch the bar activity, whether it stays down or when the power is disconnected from the actuator, that will move upward. So we are going to watch. Okay, as you can see that the bar, when actuator bar has moved upward, so when the engine reaches 70 degrees of, when the engine reaches to 70 degrees of Celsius, this bar frozen here at this position, at the deactivated position. So the when deactivated position, this bar is frozen here. So for as long as the engine is cold, the turbo actuator is working properly. When the engine reaches to 70 degrees of Celsius, this bar is seized or frozen here. Even if you turn the ignition on, off, the engine running at any position, this stays here. So for this reason, the fault code is stored in the ECU memory. So okay, ignition is off right now, and this bar is lined up with this mark right now, and ignition is off. Now I'm going to turn the ignition on. So with the ignition on, now I have just turned the ignition on, and with the ignition on, this bar didn't move. Now I'm going to start the engine and see the bar activity or reaction. Okay, as you can see, I have started the engine and the bar has moved downward. Now I'm going to turn the engine off. So I have turned the engine off, and we are going to wait for the bar movement until the bar moves to any direction or stays down. And as you can see, the bar has moved upward as soon as the power was disconnected from the bar. So this is the normal function of the actuator, the turbo vane actuator. But unfortunately, when the engine reaches to 70 degrees of Celsius or above, this activity stops. So the bar frozen here at this point here, either with the ignition off, ignition on, engine running. So for this reason, we are going to replace the turbo unit with the actuator together. Okay, as you can see, we have removed the turbocharger unit. And this is Garrett Volvo M12. And now I'm going to take that to recondition shop. So this bar was stuck at retard position. So when the engine was warmed up to 70 degrees of Celsius, so this bar was stuck at this position, at retard position. So I'm not sure whether this is faulty or the vane stacks, the vane stick due to the vanes stick due to the carbon belt inside the turbine here. And this is a 3-wire connector. So on the O2 data in the United Kingdom, only for 1 wire, the wire value specification is available. Only the power supply to the actuator here, the 2 wires, the rest 2 wires, the value the value specification is not available at all. To check the turbocharger vane position actuator, so we are going to check first the wiring diagram, and then after that we are going to check component. So this is the wiring diagram for the turbocharger vane position actuator, or Y217. So this is the wiring diagram. So when we check the wiring diagram, so this pin number 1 is going to be the power supply, and as you can see here, pin number 2 and 4 is connected. Pin number 2 and 4 are connected to the ECU pin 52 and 71. So if I go to the pin dot, also if you remember, this is 2. So if you see that pin number 3 at the sensor is connected to, sorry here, this is not this one. So as you can see, pin number 2 is connected. Pin number 2 at the sensor is connected to pin 52 connector A to the ECU, and pin number 4 at the sensor through white color wire is connected to pin 71 at connector A to the ECU. So if I go to component check here, so I'm going to, okay, as you can see, it says 1 and R. So 1 is the supply, a power supply wire to the turbocharger position actuator. As you can see, it says with the ignition on, it should be 11 to 14 volts. So checking supply voltage, test at the harness multiplug. So because the data for the pin number 2 and 4 is not available, so I'm going to go for the control module pin dot data with single turbocharger. So I'm going to select this one. Okay, as you can see, so we have got pin 52 at the pin 52 at the ECU at connector A, and they say signal condition nothing is. So connected pin here, as you can see, it says connected pin not test data, no connected pin no test data available, or random digital signal. So this is pin 52 blue wire connected to pin number 2 to the sensor, or at the sensor. So now we are going to check that the fourth wire, the number 4 pin at the sensor, which is white color, and it's connected to pin 71 to the ECU at connector A. So as you can see, they say connected pin notice data available or random digital signal. As you can see, nothing is available. So we are going to check only the wire which is connected to pin 1 at the sensor. So as you can see, so in my opinion, so this wire, green and blue, is the supply wire to the actuator, and one of the two will be ground for this wire, and the one should be used as for the treble code setting or diagnostic purpose, or that might observe the position of the actuator, at which position the actuator which is going to be. So anyway, this is not accurate, but in my opinion, this is going to be that which is not accurate. Then again, you have to follow the manufacturer specification and see the manufacturer specification value for this too. So I'm going to check this wire whether the power can be supplied to the actuator. So this is the connector I'm going to show you. As you can see, only 3 wire. The connector has only 3 wire. So pin 1, 1 second, I'm going to take the torch with me. So as you can see, we only have value specification here for pin 1, which is the supply voltage, and it says 11 to 14 volts. The rest 2 and 4, we don't have any manufacturer specification value or manufacturer specification data value. This is the supply voltage. Okay, actually we got the turbo back, refurbished. So actually the problem was the actuator faulty. This actuator was faulty, and this the internal mechanism of the actuator was faulty. When the turbo was tested or was checked by the refurbisher, they told that the actuator is faulty. The internal mechanism is sticking sometimes. It's not the part movement is not okay inside the gears. The gears movement is not good. So then we went for the complete turbo refurbishment. So we renewed this one. This is the aftermarket one. We renewed this one, and also we refurbished the turbo too. Now I'm going to install the turbo. So I'm going to install the turbo and then clear the full coat. Then I'm going to take it for a road test drive, and also I'm going to change the engine oil and oil filter too. This is Garrett Volvo M12. Okay, after installing a new reconditioned turbo unit, so I'm going to clear the fault code off. So okay, this is the fault code, and I created this one, so I'm going to turn the engine off, and I'm going to clear the fault codes. Okay, I'm going to go back, check fault code. No fault code. So now I'm going to take the vehicle to a route test drive. So I'm going to, I have started the vehicle. Okay, I have 0 trip counter here. Now I'm going to take the vehicle to a route test drive. As you can see, the fuel level is low. So anyway, I'm going to go to a previous place or same distance as I go before when the fault code was stored, and then bring the vehicle back. Okay, as you can see, I took the vehicle to 14.9 miles trip. So I have driven the vehicle for 14.9 miles or 15 miles. Now I'm going to check if the fault code has returned back. Cancel. Okay, just let me connect this. Okay, as you can see, system pass, no freeze frame, fault code detected. So we have fixed the problem. We could have only replaced the turbo vent actuator, but actually when I checked the vent condition was also not good. They were a bit resistive when you were moving the vents bar, which moves the vents. So for this reason, I reconditioned the turbo unit, and also I replaced the turbo vent actuator with the aftermarket one. So we have fixed another fault code. So thanks for watching.